Our first question today focuses on bias in language models. What is a primary source of bias in language models? Your options are A. Model architecture, B. Training data, C. Optimization algorithm, or D. Hardware limitations. The correct answer is B. Training data. We chose this answer because language models learn everything from the text they're trained on, and if that text contains human biases and prejudices, the AI will inherit and reproduce those same biases in its responses. Now, let's read the complete definition. Bias in language models refers to systematic unfairness or prejudice in AI outputs that can discriminate against certain groups, perpetuate stereotypes, or reflect societal inequalities present in training data. In simple terms, bias means unfair AI behavior. The layman explanation tells us that language models learn from vast amounts of text data that often contain human biases, stereotypes, and prejudices. If training data includes biased content about gender, race, religion, or other characteristics, the model will likely reproduce and amplify these biases in its responses. It's like learning from biased teachers. You inherit their prejudices. Simply put, garbage in equals garbage out. Our real-world example shows that if a model sees nurse paired with she 90% of the time and engineer paired with he 85% of the time, it might wrongly predict gender roles, reinforcing harmful stereotypes. This demonstrates how data patterns become AI assumptions. The memory tip states, data equals DNA of AI. Just like genetic traits pass from parents to children, biases in training data pass to AI models. Clean data equals fair AI. Remember, clean data creates fair AI. Our next question explores AI alignment. What does AI alignment refer to in the context of large language models? Your choices are A. Model parameter synchronization, B. Ensuring models behave according to human values, C. Data preprocessing techniques, or D. Hardware optimization. The answer is B. Ensuring models behave according to human values. This is correct because alignment is fundamentally about making sure AI systems do what humans actually want and value, not just what they're programmed to do. Let me read the full definition. AI alignment ensures that artificial intelligence systems pursue goals and behave in ways that align with human values, intentions, and well-being, even as they become more capable and autonomous. In essence, alignment means AI that shares human values. The explanation describes alignment as teaching a powerful assistant not just what to do, but what you actually want and value. It goes beyond following instructions to understanding the spirit behind them. A perfectly aligned AI would make decisions that humans would approve of, even in situations it has never encountered before. Think of it as AI with human wisdom. The real example illustrates this perfectly. Asking AI to make me happy. An unaligned AI might flood your brain with dopamine, while an aligned AI understands you want genuine well-being and suggests meaningful activities, relationships, or personal growth opportunities. It values your long-term flourishing, not just immediate pleasure. This shows the difference between literal obedience and true understanding. Our memory tip says, alignment equals AI plus human values. Think of it as tuning a radio to the right frequency. We're tuning AI to the frequency of human values and ethics. Remember, tune AI to human frequency. Our next question covers reinforcement learning from human feedback. What is the primary goal of RLHF in large language model training? The options are A. Reducing computational cost, B. Improving model alignment with human preferences, C. Increasing model size, or D. Speeding up training. The correct answer is B. Improving model alignment with human preferences. We selected this because RLHF specifically uses human judgment to teach AI what responses people actually prefer, making the AI more helpful and aligned with human values. Here's the complete definition. RLHF is a training method that uses human feedback to teach AI models what outputs are preferred, helpful, and safe, creating more aligned and beneficial AI behavior through reinforcement learning. Simply stated, RLHF means humans teaching AI what's good. The detailed explanation describes RLHF as having thousands of human coaches continuously improving AI performance. Humans rate AI responses as good or bad, and the AI learns to produce more responses that humans prefer. It's a feedback loop where human judgment directly shapes AI behavior, making it more helpful and harmless. Think of it as continuous human coaching. Our practical example explains how, when training ChatGPT, humans compared thousands of response pairs. If the AI wrote two different answers to "How do I cook pasta?", humans chose the clearer, more helpful response. The AI learned to generate responses more like the preferred ones. This process repeated millions of times with different human evaluators. This demonstrates learning through comparison and preference. The memory tip states, RLHF equals robot learning from human feedback. Picture a student getting constant grade feedback and improving. The AI is the student, humans are the teachers. Remember, AI student, humans as teachers. Our next question addresses toxicity detection. What approach is commonly used to detect toxic content in large language model outputs? Your options are A. Rule-based filtering, B. Classifier models, C. Human review only, or D. Statistical analysis. The answer is B. Classifier models. This is correct because modern toxicity detection relies on specialized AI models trained to recognize patterns of harmful language, which is much more effective and scalable than simple rules or manual review. Let me read the full definition. Toxicity detection in large language models uses specialized AI models to identify harmful, offensive, hateful, or dangerous content in text, helping prevent the spread of toxic communication and maintaining safe digital environments. In short, toxicity detection means AI content police. The explanation tells us that toxicity detection works like having an intelligent content moderator that can instantly recognize harmful language patterns. These classifier models are trained on millions of examples of toxic versus non-toxic content, learning to identify hate speech, harassment, threats, and other harmful communications with high accuracy. Think of it as an intelligent content filter. The real-world example shows how, when you post on social media, toxicity detection models scan your text in milliseconds. They can detect subtle patterns. "You're such an idiot" equals 95% toxic, while "that idea needs work" equals 5% toxic. The system flags or blocks harmful content while allowing constructive criticism through. It's like having a super-fast referee for online conversations. This demonstrates instant harmful content recognition. Our memory tip says, toxicity detection equals digital immune system. Just like our body fights off harmful viruses, these models fight off harmful words in digital spaces. Remember, digital immune system for words. Our last question today focuses on constitutional AI. What is the key idea behind constitutional AI? The choices are A. Using legal documents for training, B. Training models to follow a set of principles, C. Government regulation of AI, or D. Formal verification methods. The correct answer is B. Training models to follow a set of principles. This is right because constitutional AI gives language models a written set of moral guidelines that they can use to evaluate and improve their own responses, rather than relying solely on human feedback. Here's the complete definition. Constitutional AI trains language models to follow a written constitution of principles and values, enabling them to self-correct and make ethical decisions based on clearly defined rules rather than just human feedback. Simply put, constitutional AI means AI with moral rules. The explanation describes constitutional AI as giving an AI a moral compass with written directions. Instead of just learning from human feedback, which can be inconsistent, the AI learns a set of principles like be helpful but not harmful or respect human autonomy. The AI can then use these principles to evaluate and improve its own responses. Think of it as AI self-governance through principles. Our real example shows an AI with principles like don't help with illegal activities and respect privacy. When asked, how do I hack into someone's email? The AI checks its constitution, realizes this violates privacy principles, and instead explains email security or suggests legitimate ways to recover lost passwords. It self-governs using its built-in principles. This demonstrates principle-based decision-making. The memory tip states, constitutional AI equals AI with a moral GPS, Just like a GPS guides you to your destination, constitutional principles guide AI toward ethical behavior. Remember, moral GPS for AI decisions. This completes our journey through essential LLM safety concepts. Keep building the future responsibly.